Very question, we want to use nodal analysis to solve for ix. We can see the position of ix there, and we say that first of all, when we have a network, of a network this way, we can first of all assume current in the arms where there is no direction of current. Okay, so we can call here now, we call here I1, we can call the current here I1. We assume a direction that way, we can call the current here I2, okay? And we can call the current here I3, and we call the current here I4, okay? So we now consider KCL in each of the junction, then converting the current to voltages, to the nodal voltages. You can see the node voltages V1, V2, and V3, okay? So we start with node 1. At node 1, what is the relationship of current? We can see that I1, and the amount of current entering is I1, I2 and IX is leaving, so we can say I1 is equal to I2 plus IX. Now to convert this to node voltage, our I1, like we see, if you see the direction of I1 is equal to minus V1 all over 10. Minus V1 because the current is entering into V1, so minus V1 over 10. If the current was leaving V1, it would have been plus V1 all over 10, okay? So your I2 is going from V1 to V2, so that means the voltage there is V1 minus V2 all over 5. That means voltage over the resistor, V1 minus V2 over 5. Then your IX is actually moving from V1 to V3, so it means I'm going to have plus V1 minus V3, then all over the resistor there is 20, okay? So if we find LCM, multiply through by 20, to simplify this, we're going to get this to be minus 2V1, okay, equal to 4V1 minus 4V2 plus V1 minus V3, okay? This is a plus. So collecting like terms now, we are going to get 4V1, 7V1 minus 4V2, then minus V3, all equal to 0. So you can write that out somewhere. 7V1 minus 4V2 minus V3 equal to 0. Okay, so we look at node 2 again. Let's look at node 2. Now at node 2, we can see again, remember, let's pick our current position. We have this here, we have this here, we have this here, then we have this here, okay? So when we look at node 2, the current entering node 2 is the 10 amperes, and the one from V1 to V2, while the current leaving, this is our I2, remember? These are I3, and these are I4, and these are I1. Okay, so from V1 to V2, we can say the current entering is 10 amperes, now plus V1 minus V2 all over 5, okay, equal to the current leaving. The current leaving is going from V2 to V3, so we have V2 minus V3 all over 10, okay? If we multiply through by the LCM by 10, we are going to get 100 plus, this is going to be 2V1 minus 2V2 is equal to V2 minus V3, okay? So if we bring all on one side, we are going to be getting 2V1 minus 3V2 plus V3 all equal to minus 100. So you can write that down somewhere. 2V1 minus 3V2 plus V3 is equal to minus 100. Okay, so we look at node 3. Let's erase this and look at node 3. Now, if you look at node 3, the current entering node 3 is I3. IX is entering node 3, but I4 is leaving node 3. Okay, so that means we are going to get IX, okay, plus I3 equal to I4. Now our Ix going from V1 to V3 means V1 minus V3 all over, this is 20, plus our I3 is moving from V2 to V3, so we get V2 minus V3 all over 10 equal to I4. I4 is going away from V3, so that's going to give us V3 over 5, okay? So we can multiply through by the LCM, which is 20. So we are going to get V1 minus V3, okay, plus 2V1 minus 2V3, okay, this is a minus, now which is equal to, here is going to give us 4V3. Now if we collect, if we bring all together, we are going to be getting 3V1 minus 3V3, okay. Sorry, that's a mistake. This should be a V2 here. So let's rub off our mistake. So if we continue from there, we are going to be getting V1 plus 2V2. This is going to give us plus V3 all equal to 0, okay? So here we have, you can write that down, V1 plus 2V2 plus V3 equal to 0. So we can write out all our equations that we have developed so that we can find Ix. The equations, the first equation, we have 7V1 minus 4V2 minus V3 equal to 0. The second equation is 2V1 minus 3V2, okay, plus V3 equal to minus 100. And the third one is V1 minus plus 2V2 plus V3 equal to 0. Okay, so we can solve equation 1, 2, and 3 simultaneously. And if we do that, we are going to get is equal to 5.26 volts. Okay, V2 is equal to 21.05 volts. Then V3 is equal to minus 47.4 volts, okay? Minus 47.4 volts. So that now leads us to finding our Ix. So now we can find Ix. What is Ix? You can write that out. What is Ix? Ix now, based on the question, is V1 minus V3 divided by 20. Okay, remember our V1 is 5.26. Then minus V3, our V3 is minus 47.4. Now divided by 20, okay? So that is going to give us 52.66 divided by 20. And that is going to give us 2.633 amperes. Thank you very much. Please don't forget to subscribe to our YouTube channel. Just click the subscribe button. Thank you. Have a lovely day.